So this lesson is all about exponential growth and modeling exponential growth using functions and also sequences. And I really think the lesson does a good job here with this mice analogy. So I'm just going to talk about that a little bit. You have 6 mice in a large cage. The population will double every month. Write a function for this situation. So if you're doubling every month, that's exponential growth. And f of x equals ab to the x is the general formula for exponential growth, where b is greater than 1, a is your initial amount, and x is your input of time, or whatever your input is, and f of x is the output. So in this case, we're talking about time and the number of mice. The initial amount was 6 mice, and they said doubling every month, so the growth rate is 2. And then x is the number of months. So then you can figure out however many mice you have using this function, any number of months. So you could say, okay, in 5 months from now, I'll put a 5 here for x, and then do 6 times 2 to the 5th power, and that'll tell me how many mice. So f of 5 equals 6 times 2 to the 5th. 2 to the 5th is 32. I had to think about that one for a minute. So f of 5 is, I'm going to show you a mental math trick here. I'm going to do 6 times 30 plus 2, like that. 6 times 30 is 180. 6 times 2 is 12. Add them to get 192. So that's how many mice you would have in 5 months. You could also model this as a sequence, just listing the number of mice. So it's 6 times 2 to the x. So I'll start with a 0 to get the first term. 2 to the 0 is 1. 6 times 1 is 6. So my first term will be 6. And then input a 1. 6 times 2 to the 1. 2 to the 1 is 2. So 6 times 2 is 12. And the next one would be 24 and 48, because I'm going to be doubling each time. That's what that growth factor of 2 means, 96. So you can also make this into a sequence. And you're also going to be looking at compounding interest, and there's a formula for that, but I think that's pretty clearly explained in the lesson as well. So that's the big picture.